Hey, what's up? Welcome to Hacking Smart Contracts for Fun and Profit. Let's get into it. Today we're going to be looking at Damn Vulnerable Defi, created by Tincho Abate. Sorry, man, I probably totally butchered your name. He's one of the guys over at Open Zeppelin doing some really awesome work over there. So we're going to be looking at Challenge 1, Unstoppable. So there's a lending pool with 1 million DVT tokens in balance, offering flash loans for free. If there was a way to attack, if only there was a way to attack and stop the pool from offering flash loans. You start with 100 DVT tokens in balance. Cool. Let's check out. Okay, the first contract. It's made up, we have two contracts here. We have a receiver, unstoppable, and we have unstoppable lender, which is the flash loan contract. So here, looking into it, at the top, we have interface, I receiver, and we have a function, receive tokens. Scrolling down a little bit, we get into the contract here. We're inheriting from reentrancy guard. We have a couple variables at the top. Damn Vulnerable Token, which is an IERC20 token, and we have pool balance. The constructor, we're just initializing this IERC20 token, and going down we have a function, deposit tokens. So here we do a couple checks. We require the amount deposit at least one token. Cool. And then we transfer from message sender. We send them. We transfer from the message sender into this contract, and then we do some accounting down here. We add the pool balance. We add the amount to the pool balance. The next is the flash loan function. So we have a no reentrancy modifier, and then we do a check. We must borrow at least one token. It's a good idea. We do check here, the balance before. The balance before is greater than or equal to the balance amount. So this makes sure there's enough tokens in the pool to borrow. And then we assert the pool balance is equal to balance before. Make sure nothing funky is going on. We transfer the tokens, and then we trigger this receive tokens function, which is in this receiver unstoppable contract, and then we make sure the flash loan's paid back here at the bottom. Okay, pretty basic. Let's go over and check the receiver contract. What do we have? Okay, so at the top we got a couple variables: pool, owner. This is a reference to the flash loan contract. In the constructor, we initialize these variables. So pool equal to unstoppable lender. This is creating an instance of this flash loan contract, and then owner is just message us sender. Cool. So this function, the receive tokens, this is the function from the interface on the other contract. We can see here, receive tokens. This is the iReceiver. This is from the interface. So this is what's being triggered. So we would trigger, when we call flash loan, we trigger this receive tokens function. We do a check to make sure the address is the pool, and then we make sure the transfer goes through. Otherwise, we'll get an error here. And the last function is execute flash loan. We just do a check to make sure the message sender is the owner, and then if it is, we call the flash loan. Cool. So nothing too crazy here. The only thing that stands out is the fact that we're working with an ERC20 token, which we can see here. IERC20, this damn vulnerable token, is an ERC20 token. So what that means is we have access to all the functionality of that ERC20 token. So why is that important? Well, it's important because right now it looks like the only way to transfer money into this contract is through this deposit tokens function. But it's actually not the case. We can use the ERC20 functionality and all the functions that's available to that token on this contract here, because we're inheriting from the ERC20. So ERC20, it has a function called token.transfer, or just transfer actually is the function called. So we can call transfer to forcefully transfer money into this contract. And why do we want to do that? Because what will happen is it will offset the pool dynamic. And when the pool dynamic is offset, we are going to not be able to pass this this line of code right here. Assert pool balance is equal to pool balance before. We're going to basically break the contract right here because it's not going to be equal anymore. So after that, the contract is going to be hooped. Let's do it. So here is our tests. We're working with hard hat here and ethers JS. This is just a basic test setup. We're creating some variables for tokens in the pool, initial attacker balance. Then we do the setup scenario here. We're setting up the token, setting up the flash pool, and then we're transferring money into the pool, transferring money to the attacker address, and then we're expecting the right balances to be in the pool, expecting the right balance to be in the attacker address, and then we're just testing the functionality of the flash loan. So here we go. This is where we're going to import our code. So basically all we have to do is call transfer on the token, transfer our tokens into the flash pool. That's going to offset the balance and break the contract. So let's give it a try. Token. We have to connect our attacker wallet. This is a hard hat thing. And then we call the function transfer. We want to transfer to the pool. And we want to transfer all of our initial tokens. Okay, that's basically it. So if we did this right, we should break the contract. Let's hack it. All right, let's try it out. And run. If we want, actually, we can just say yarn run. And then we can look at all these different challenges. We want unstoppable. Unstoppable. And let's try and run that. Come on, boom. And we passed it. Okay, there we go. So that's challenge 1 for Damn Vulnerable Defi. And stick around, we're going to go through the whole series, and we'll see you next time.